So this is our MEP session. High performance architecture of passive house may use more enclosure materials to construct, but their mechanical systems can be smaller, reducing embodied carbon in that respect. Additionally, passive house buildings' impact on electrical grid peak loads improves resiliency and facilitates our conversion to renewables. However, we need to be extremely judicious and careful with our usage of refrigerants. This session will highlight the building system's role in the whole carbon picture. First, we will hear from Yasmin Kologu, principal at SOM and founding board member of MEP 2040. Then Nikita Jathan, senior environmental designer at Atelier 10, will present an exciting case study. And finally, Ed Ettinger, a managing principal at Ettinger Engineering Associates, will speak in general from the engineer's perspective.
Perfect. Hopefully this is going to work. Is this what I'm clicking? Perfect. Okay. So let's start with saying that I'm actually an architect by education, but today I'm going to be talking about MEP 2040. And hopefully this is an omen to the idea that we have to collaborate. If we're going to get there, we're all going to get there together. So I believe that our lines are blurred and they're going to get more blurred, and we have to continue our collaboration in this matter. Thank you for that. I don't have my colleague today, Stefan, but so this idea was born from a couple of years ago. We thought, we have architecture we have AIA 2030 commitment, we have SE 2050 commitment for structural engineers. And how come we don't have MEP one? And how can we get there if you're not all working towards similar goals? So we reached out to Carbon Leadership Forum to actually start a pledge that would be specific to MEP engineers and the priorities that we see in that world. So what is it? It is actually a commitment that suggests that all system engineers should advocate for and achieve net zero carbon in their projects, operational carbon by 2030, and embodied carbon by 2040. And it was quite crucial that we do not set new targets, but we work with targets that already exist in the industry to be complementary to each other. And what are we asking for? So it's actually quite straightforward. Establishing a company plan on how we're going to get there, requesting low refrigerant availability in our projects, and requesting EPDs for MEP components, and finally, enable to an ability to participate in the quarterly MEP 2040 forum to exchange our learnings, ideas, what works, what doesn't. So this is those of us in the steering committee, and you can see it's quite a diverse group of people from different disciplines in the building industry. And we believe that this kind of representation is essential for the success of this kind of effort. And hopefully you're also seeing some familiar faces here too. And since our start, currently we have many signatories on board, but we also have a second group who are the supporters. So either we sign up as MEP engineers, or supporters can be other organizations who might not have MEP in their services, yet they do believe in the similar aspirations that we all share. So let's start with what does it take? So establishing a company plan. So in this one, simply, we're actually asking to reduce to set a plan together, to put a plan together, how we're going to get there, how we're planning to get to 2030 for operational and 2040 for embodied carbon, setting targets, understanding some actions, and defining our own priorities. And this is actually, we don't have a set formula for this, so that every company can actually set their own goals to get there. And a sample example, and if you go to mep2040.org, you'll get many others, but again, a good example from Brewer Happold, how they're approaching this to give you an idea of what these commitments might look like. So our second ask is refrigerants. Asking low impact refrigerants is what we're talking about. And we know that, a significant impact on the environment, and especially immediate impact on the environment too. So how can we request low GWP refrigerant availability in our projects? And we actually have a tool that you can access from the same website also. That is a refrigerant impact calculator that many of us probably have seen or are using in different projects to check the impact and reduce the impact of our projects too. The third one is requesting environmental product declarations. And why so? MEP products have been actually left behind a little, historically, they had been left behind a little bit in this realm. When we talk about particularly global warming potential and embodied carbon. So we are seeing more and more in the market, but we believe that there's more space there. So we're asking our members to request environmental product declarations from producers. And why is it important? Because we need to make informed decisions, just like the rest of the building components. And EPDs allow us to actually see the global warming potential of our selections and systems. And we know that EPDs take time. So there's actually a timeline put together that we know it takes about 2 years from the moment we ask. So we're seeing more and more coming on the market. And we believe that it's a market that's going to grow quite steadily and quite fast as well. And the final ask was contributing to a growing body of knowledge and sharing our knowledge, what works, what doesn't in the built environment. So simply actually participating in our quarterly forums and join a working group that varies from communication to data, more technical information, partnerships, and also EPDs are some of the working groups that we have today. So hopefully it's pretty straightforward, and maybe we can entice some of you to join as well. And in the just to look back, maybe what happened in 2022, and we'll look forward a little bit after that too. Basically, we have at the moment 58 signatory MEP firms, and we have about 100 plus working group members, and we have 30 supporting organizations for this effort. And we have four quarterly forums we've had for last year. And also there are some resources that will be available in the MEP24.org page. So you can access the tools that I talked about. You can access some of the information and more detailed explanation about what the membership takes and what are some of the information and tools available to all of us. And then for next year, we'll finish with looking ahead, what might happen next year. So we have already grown our impact by square meterage significantly. And you can see that we're continuing to grow in all continents. And we hope that those of us in the room who are working on significant projects will join this effort too, so we can actually grow our footprint even further, our impact further. We're looking at many companies joining us in this effort. So the draft plans questionnaires due in this year, actually. So you'll see some of them in here. So we're growing our knowledge, the plans, and knowledge sharing. And finally, as part of our program, we are seeing that more embodied carbon data coming in for MEP systems as well. And we believe that this is also a much needed improvement to what we have today. And this is my last slide. So hopefully this gives you an idea of what MEP 24-day pledge is, what kind of change we're hoping to make and starting to make. And hopefully we can entice some of you to join us too. Feel free to reach out, and also the MEP24.org has a lot of information for all of us to check out. Thank you.
All right. Hello, everyone. It's a pleasure to be here as part of this session today. Yet again, not an engineer, but we will get to have one as part of this panel coming up after me. Let's see. Do I need this? There we go. All right. So today I'm going to be providing a quick overview of the Silvio J. Malo Federal Building Modernization Project located in Lower Manhattan. My name is Nikita Jathan. I'm a sustainable design consultant with Atelier 10. And while our firm addressed sustainability on this project, and I have the privilege and responsibility of giving this talk today, I by no means did this alone. This ambitious project is the result of a large integrated and dedicated team of firms, Kirk Sexton Partners, Thornton Tomasetti, and WSP Engineering, just to name a few whose work I'll be highlighting here today. And of course, we worked very closely with the United States General Services Administration and the U.S. Attorney's Office. But before I get into all that, zooming out for a moment, today's event is exploring a scalable, comprehensive approach to reducing carbon emissions. And in our work as a firm right now, we are actually shifting away from an approach to net zero carbon, and I think and toward what we're calling absolute zero carbon. And I think this offers a really valuable framework for us to evaluate our projects and think about the one I'll present today. Obviously, I don't need to dwell on this. We've talked about this a lot today, but we're all aware that we have very limited time to mitigate the impact of climate change. But this requires real change from our industry. Sustainability and the green building movement have obviously shifted how we build today, but more change is required. We frame so much of our work today, and I talk about it every day in my projects about net zero carbon, but that still means that time valuable emissions are happening now. We must move away from an offset focused solution and reduce absolute emissions now. So here's a roadmap that we're proposing for every building, development, and master plan. First and foremost, passive all-electric design. Through passive and active strategies, we can get to ultra-low energy operations in our buildings and have those buildings then be well-equipped to respond to blackouts, extreme weather, and increasing temperatures, all climate hazards of which are already here. Next, create 24/7 renewable energy so that even when our buildings continue to be connected to the grid, we never have to rely on fossil fuels. This is likely going to require thinking about not only on-site renewables, but also off-site renewables, energy storage, microgrid, a variety of renewable energy strategies to get there. We need to use materials that are zero embodied carbon or carbon sequestering. Mass timber is obviously a start, but we need to transform the materials industry to eliminate materials that cannot be made sustainably, reduce waste, and improve the livelihoods of the many workers involved in materials manufacturing. This step is obviously a huge challenge and potentially the furthest from being market ready, but it's obviously so relevant to our event today, and it's been great to hear about progress in this arena. We need to design adaptive reuse that is as good as new construction on operational carbon and obviously better on embodied carbon. Repurposing existing buildings not only saves carbon, but it also preserves space, valuable open space that we need to use for high-performing landscapes that can sequester carbon, which brings us to serious protections for functional ecosystems and landscape and rehabilitating developed landscapes to sequester carbon and support habitat. Over time, landscapes are really an opportunity that can take us from absolute zero carbon on day one to carbon positive. And it becomes even more meaningful to me when we can think about landscape beyond the parcel boundary and at a community scale. And finally, we must move away from our reliance on single occupant vehicles. Otherwise, we risk undermining all the great work that's being done to decarbonize our built environment through projects like the one I'll talk about today. Now, the project I'm about to present is not achieving all of these targets, but framing this project in these terms, I think helps us celebrate the progress that we have been able to make, emulate successful strategies, and identify that there is still plenty of work to be done. So now onto the project, the Silvio J. Malo Federal Building Modernization Project. This 10-story building was constructed in 1974. It houses the U.S. Attorney's Office for the Southern District of New York, as well as the U.S. Marshal Service. And now the project's original goals are listed on this slide, relatively straightforward. First and foremost, to modernize this facility, create a high-performing building and enclosure, maybe one that's a little bit prettier while we're at it, while maintaining the building structure and achieving LEED Gold. Now, maintaining the structure was really, I think, a monumental and pivotal decision from a sustainability perspective. When considering the sheer impact of that decision on the building's carbon footprint, it set the tone very early on for us as a team to ask, how much further can we go? How can this building be a truly exceptional example of adaptive reuse? Fortunately, as a client, the federal government was incredibly supportive of this opportunity. The General Services Administration and the Public Building Service already require a high level of sustainable performance for new building projects. But while a big focus, I think, has been historically on operational efficiency across energy and water, more recent strides in creating low embodied carbon materials guidance for federal building projects really further expanded the project's sustainability ambitions early on in design. And we saw an opportunity here to build momentum for sustainable design policies, pilot strategies, and create a new example for what existing building reuse could really look like. So those evolved ambitions have resulted in an incomplete but a long list of exciting sustainability features here that I'll kind of whiz through. The building is all electric on day one. By optimizing energy use, building systems, and a high performance envelope, we were able to get this building down to an EUI of 30 based on our latest energy modeling. This focus on passive design has allowed this building more than one approach really to reduce peak demands in a demand response event while also keeping occupants safe and comfortable. To further reduce that EUI, we've also been able to include renewables on this urban Lower Manhattan site. This required some major negotiation of roof area to allow for rooftop solar, but we were able to go even further and integrate solar PV into facade fins. In addition to the reuse of the building structure, all new structure and enclosure materials are still optimized for low embodied carbon design. I'll talk a little bit more about how we got here, but we have been able to design in rainwater collection, not only to manage rainwater on site, but to offset all on-site irrigation demand and a majority of the building's flush fixture demand. I have personally been through numerous failed experiences trying to get water reuse in on projects. And so this one is one I'm particularly excited about. We were also able to successfully limit dedicated parking since we are privileged to be in an area where the project is very well served by transit. And though we were pretty limited by the available site area, the team has been able to accommodate a variety of outdoor spaces and bicycle storage. These were really important to the user experience because we know that the occupants of this building used the building for very long stretches of time in the U.S. Attorney's Office. So that attention to high quality environments really extends through the entire interior experience, optimizing views, daylight, and sustainable and healthier material selection. So this whole cascade of efforts to push a holistic sustainability story went obviously hand in hand with an elevation from our LEED Gold minimum target to a LEED Platinum target. But going even further, it was fairly clear to the team early on that the project aligned with an approach towards zero carbon. And so the project is actually positioned to pursue a zero carbon certification as well. To illustrate how a few of these key decisions, I think, have really shaped the project's carbon story, I want to spend a little time digging into a few processes that I think have set this project apart. I'll start with our approach to embodied carbon through the building structural systems. So Thornton Tomasetti Engineering, obviously not here with us today, but contributing some great content to these slides. TT worked on both structural and facade engineering, which you'll see resulted in a pretty synergized approach. As described in the words of our engineer, working with existing structures is a form of reverse engineering. A full evaluation of the structure was required to ensure that it aligned with modern codes in the updated design. So the team actually worked off of as-built drawings as the primary source of information for the existing structure, but those drawings were often imperfect, incomplete, oftentimes barely legible. So testing for validation was required and often led to surprises. Testing one floor slab, for example, indicated that concrete strengths were nearly 40% lower than the intended design strength, even after decades of curing. Additional cores that you see on this slide were actually taken to validate those initial results because they were just so low. The team was also missing reinforcement drawings for the concrete shear walls in the project. The team had originally planned for 4 new shear walls to bring the building up to modern code. Thanks to a series of probes to validate the existing rebar size and spacing, we were actually able to justify the removal of 2 of those 4 proposed shear walls, which I think is a really great win for our carbon story as well. Really just, even though there's a lot less time spent drawing and detailing structure since that already exists, significant time is still spent testing and performing analysis to justify less structural intervention, and when possible, none at all. Final structural example here, the slab geometries themselves impacted our approach to both program and facade design. Adding slab area to infill the existing massing actually added significant square footage to the building, but the low strength, lightweight concrete in those slabs presented some challenges for the facade. Direct connection was impractical when considering blast loads, which there are requirements for in this building. And steel members had to be strategically chosen to avoid overloading existing columns and also minimizing the particularly high embodied carbon options like cold rolled steel tubes wherever possible. So the impact of these structural decisions, I think, is clear when we consider the emissions. Reuse of the existing building structure is expected to reduce emissions over 40% over a baseline equivalent building. When also accounting for optimizations in new structural system materials, the enclosure, and in interiors, we're estimating a 55% reduction in global warming potential over an equivalent new building. Now, the project is still wrapping up design, but all of these targets have been built into specifications, and we've been investigating procurement options for a significant amount of time. And so you're hopeful for a successful approach, but these are all still estimates. So that brings us to operational carbon optimization. Several facade options were compared and analyzed early in design, both by Atelier 10 and TT facade teams. They varied in their balance of opaque and glazed areas, shading opportunities, and thermal performance. Ultimately, this has led to a facade that very intentionally places glazing to optimize daylight, views, visual, and thermal comfort, along with whole building performance. The scheme of the current building is actually at about 35 to 36% overall window to wall ratio, but that's actually 53% when you're looking at a typical office floor. All opaque areas are critically considered for performance as well to help make up for that, including placement of insulation even behind mullions. Even after selection of an initial facade design, we've continued significant analysis to just further optimize the facade. Our team actually took a facade by facade approach, ensuring whole building performance drivers were considered along specific program needs in various places in the building, and that the facade balanced, I think, a healthy amount of character and interest and relation to its surroundings without including superfluous additional material. These kinds of conversations, I think, led to matrices like this one, where we systematically addressed how facade elements mitigated solar gain, maybe meaningfully impacted visual comfort in ways that the program really called for in those areas, contributed to embodied carbon through simply, their materiality, and potentially even could save emissions by generating energy as facade integrated solar PV. So based on the payback of that emissions trade-off, we enabled the team to help just make more informed decisions. So after highly optimizing the facade, we considered systems design with the WSP engineering team. The objectives for building systems were clear from early on: decarbonize, electrify, sever an existing steam connection at the building, following the above objectives, and pursue energy efficiency. Now, a whole host of systems were reviewed to reach a design that included cooling provided by water-cooled chillers with a cooling tower and air source heat pumps instead of boilers, originally that utilized for heating throughout the year and then cooling during shoulder seasons. Now, though the evolution of these system selections made sense, the team actually stepped back in mid-design to review the ways that the approach could be improved, and ultimately ended up pursuing a design that is actually slightly less energy efficient than the design just described, but streamlined for many other reasons, which I'll explain now. This alternate design, an all air source heat pump design, was shown to actually better serve the project when considering a holistic sustainability approach instead of simply zoning in on operational energy efficiency. So while taking a slight penalty due to marginally less efficient operations, the design was able to remove a significant amount of equipment from valuable roof area, including cooling towers. This roof area made way for an expanded rooftop solar PV array. The alternate design also just simplified operations to just one system, which we felt like increased likelihood of operational efficiency and decreased operations and maintenance costs and complexity. Going further beyond energy efficiency, this design change resulted in major impacts to the design's water story. Now, the two images on the right represent the water balance of the project. First in the cooling tower design scenario on top, and then the all air systems design on the bottom. Each graph shows the building's water demands across the top of the graph, and the potential supply volume across the bottom. Now, removal of the cooling towers alone shifted the water balance of the project to balance its overall project demands much better with the amount of rainwater that could be potentially collected on an annual basis. And then due to significant savings in first cost in changing system designs, we were able to actually take that net funding and reallocate it to be used for rainwater collection infrastructure to offset the majority of the building's toilet flushing demand. So with the removal of the cooling towers and on-site reuse of water, the project is actually estimated to save over 650,000 gallons of water each year. All of this to say, removing energy efficiency as the lone driver of system selection actually resulted in a more efficient design when it came to structure, space, operations, and water. So again, a holistic carbon approach. And then to round out the approach to operational carbon, there are actually two forms of renewables included on this project. We have rooftop solar PV currently estimated to generate close to 120,000 kilowatt hours a year. Solar PV is also integrated into the building's fin design on the facades that are indicated in the image. Those are expected to generate around 20,000 kilowatt hours a year. All of that resulting in the combined design to offset over 10% of the building's estimated energy demand each year. And I think for this building's location and density, we've found that to be really exciting. So zooming back out, a baseline building of this scale obviously has a significant emissions footprint, both on day one, considering emitted embodied carbon of its building materials, in addition to cumulative operational emissions over time. We've been able to bring that initial impact down significantly on both fronts, cutting both embodied and operational carbon emissions by about half. But we know that these are still emissions, and they still are time valuable. So the project will be procuring offsite renewable energy to offset the remaining energy use. And we are continuing to explore more meaningful methods to offset the embodied carbon still associated with the new construction portion of the design. But ultimately, returning to this framework, I think helps us put these decisions in perspective. Passive, all-electric, and adaptive reuse design in a well-connected site here shows that it is possible to move in this direction. And with the help of all of our industries and the great ideas that are being exhibited today, we can get to absolute carbon, and we must. Thank you.
Hello, I am Ed Ettinger. I am the managing principal of Ettinger Engineering Associates. We're a 75-person MEP and sustainable consulting firm in Midtown. And I guess I feel obligated to disclose that I am an engineer. So yeah, that's right. Although I echo Yasmin's message that obviously the whole idea of this talk and the way we behave should be all inclusive. Because I constantly challenge our staff to think like others at the design table, so that we can really approach carbon neutrality in all ways together. The purpose of this talk is to kind of jump past some of the obvious things that we are already trying to do in buildings, which is to electrify, put solar panels on roof. And I want to bring you to how we are dealing with the leading edge of MEP design, and in a way, give you a window into this world and empower you to kind of challenge the MEP engineers and sustainable consultants that you deal with to push for more. Oh, gotta go up. I want to go down. It goes up. So I'm going to start briefly talking about Passive House, which is one of the cutting edge frameworks that we use to push building certification to lower operational embodied carbon and just cut specifically to how that benefits MEP systems. I'm going to spend most of the talk talking about, again, leading edge opportunities for us related to Passive House, more related to electrification, MEP 2024 in the city, in the state, and beyond. And then I'm going to leave us with a challenge. So hopefully many of us know about Passive House, right? One of the core tenets is that we build a building with a super efficient building envelope. And from an MEP perspective, this immediately translates into lower loads, smaller equipment, which translates directly into lower hard costs, lower operational costs, lower spatial impacts of MEP equipment. This is a nice graphic from PHI that shows quite literally that the heating energy demand from, an older code building to a Passive House code building can literally be reduced by 75%. So this obviously has a direct impact for us. I keep wanting to go down, I'm sorry. One of the second tenets of Passive House is to bring a healthy building environment, right? We build a very tight envelope, and we take control of infiltration in and out of buildings. We don't want uncontrolled exfiltration, infiltration. We manage ventilation with high efficiency energy recovery ventilators, which are basically glorified heat exchangers. As we relieve air from a space, as we exhaust air from a space, it's already cool, it's already heated for our comfort. Why throw that energy out the door? Let's give it back to the incoming air, and we can do that nowadays with 85% efficiency, and we do this routinely on Passive House projects. This also provides direct operational carbon reductions and cost reductions and other indoor air quality co-benefits. Gonna get up eventually. Speaking kind of to the message today, right? I want to get us thinking about Passive House and the co-benefits for the metropolis, us as a collective, stepping away from a building into how this really helps us at a larger scale, right? So as Sarah mentioned in the introduction, there is less, with smaller systems, there's less embodied carbon on site, kind of in two ways. First of all, on a traditional project, maybe we put 100 tons of mechanical equipment in. Maybe it's 50 tons with a Passive House. So literally, there's less metal, there's less piping, there's less transportation and embodied carbon in the material that way. But additionally, there's a lot less refrigerant charge on site. And we're going to speak about global warming potential embodied in mechanical equipment systems in more depth in a couple of minutes. An additional co-benefit for the metropolis of Passive House is that as we reduce our heating loads and we reduce our cooling loads and we bring our energy targets, our energy down within the building, the grid benefits substantially. The grid here, the grid nationally, the grid everywhere struggles as climate change does just a couple things kind of going on at once. First of all, climate change makes extreme heat events much more prevalent. We have more brownouts, we have more blackouts, and the grid is struggling to deal with this. So if we can bring the energy demand of buildings down, the grid will be more resilient in the long term. Additionally, as we make this transition, it makes the grid more able to convert to renewables as well. Renewable sources like solar panels, wind, water are not as great as fossil sources of power at handling peak loads. We need batteries and stuff. So as we peak load shave through design process and certification like Passive House, we're also doing a big service for the grid. I'm never going to get it, I don't think. Okay. So let's start to step away a little bit from Passive House, although this is still kind of a Passive House based slide. And I want to bring you right to the front line of some of the things that we're dealing with in our space. One of them is trying to reconcile Passive House with packaged, localized mechanical systems. So Passive House asks us to improve the envelope and control ventilation. And we don't want to make holes. We don't want to make thermal bridges through the envelope. On the flip side, as we start to think about the carbon embodied in refrigerant and global warming potential, there is a kind of small tete-a-tete forming because I want to bring, traditionally Passive House is done with a split system. I put a condensing unit on the roof. I have a run out of refrigerant piping, and I don't have a facade punch like is shown in the picture in the middle, and I picked an ugly one to really kind of drive the point. We don't want that facade punch. We want to bring package systems closer together for two reasons. One, package systems are in general cheaper for mechanical design. And also, we don't want all the refrigerant embodied in the split. So we're actually making progress. We have about 5 or 6 projects that are finding ways to put packaged systems with facade punches in passive projects and move to get them certified. One of them is actually an NYSERDA Buildings of Excellence project. So thank you, NYSERDA. I think NYSERDA is in the room. And so there's kind of 2 approaches to this, right? The picture on this side is there's kind of coming out of Italy. There's an Italian consortium that's looking to modernize the PTAC in a way such that instead of this 42-inch by 16-inch punch in the facade that is the traditional PTAC, manufacturers have found a way to deal with all the process air that a PTAC needs for heating and cooling an apartment, let's say in 2 6 to 8-inch round holes. So that's one way that we are starting to limit the thermal bridge through the facade, limit the infiltration, exfiltration that can happen, and the lack of insulation that occurs at this punch. The picture on the opposite side over here is more about what the traditional PTAC manufacturers are doing to turn the system into a mini split. They're actually splitting the equipment by about 8 inches and put a high insulative, an R6 style spray foam insulation in between the indoor and the outdoor section, where we can actually turn the PTAC punch in the middle. Instead of being R.5, we're getting to R10, R12, R18 values that start to reconcile with the tight envelope performance and the energy performance that we want for the building. So hopefully that gives you one thought process about how we can try and break our minds into heading towards packaged systems while also bottling up our envelope. Let's turn away a little bit from passive house and start to talk about electrification, not just electrifying building systems. Our office and a lot of the mindset of 2040 has already kind of started to take electrification for granted because the systems are carbon neutral ready. We're waiting for the grid to catch up and decarbonize. So we're already electrifying our systems, but where do we struggle? Commercial kitchens don't like to electrify, and there's in general a wishy-washy acceptance of induction cooking, let's say, right? So let's talk about commercial kitchens first as related to the throes of commercial lease-up. A lot of the work we do 75% of the work that we do is in the city, maybe 25% in the state and beyond. I feel very fortunate to be working here in the city of New York, and I'll tell you why. First of all, the city came in 2019 with Local Law 97, which is the carbon tax, right? So that is pushing buildings, tenants, operators to electrify systems with a financial driver. Next to that, the DOB is putting increasing pressure on gas piping. They're driving up inspection requirements. There's different welding qualification requirements for gas piping. So there is, I wouldn't say that it's an overt assault on gas piping, but it is in a way, perhaps something like that. We have in affordable spaces, we have the state HCR and the city HPD, who basically subsidize and incentivize affordable housing developments, starting to require and mandate electric cooking, and in some of the latest initiatives, push for induction, right? So this has set a nice stage, but at the same time, the front line for me and for the integrated consultant team is translating this into the actual implementation of electric cooking. So what does a developer want? A developer wants the flexibility to lease a space. They want as many options as they want. We also have a gas ban in New York City that's going to take full effect in 2027. So we have that going for us too. But so like on one extreme of the perspective, a developer might say something like, give me gas or give me death. I get that type of thing. Some might say to me things like, actually, if I get gas in this building for cooking, I might be one of the last modern buildings to have it, and it could be a differentiator in that regard. On the other side of the spectrum, there's a lot of other positive pressure to drive to electrify. Underwriters and lending institutions have gained an understanding of Local Law 97. They're asking building operators and tenants to make sure that they have the financial wherewithal to handle carbon taxes. So that is one reason where we're getting one area where we're getting help to push to electrify buildings. And also some of the building operator responses and owner responses to this have been to try and push the carbon tax on the tenants. So we did a fit out for one of the leading barbecue chains in the city in Brooklyn, and they actually demanded retrofit because they wanted induction cooking. It was part and parcel with who they are, and also because they wanted to avoid carbon tax. So the short of what I'm saying is there's no immediate strategy or answer that helps guarantee that we can electrify cooking, but hopefully you've heard some of the strategies and thought processes around how we're dealing with it and trying to set context, right? Part of the battle is also education. Right, I still have some developers and some teams that don't know what Local Law 97 and the carbon tax is. So if I'm able to frame this in that context, then I can help set an understanding and really drive why we might want to electrify systems. That brings me to the picture of the eggs. A lot of people still don't even really understand what induction cooking is. It is lower energy consumption electric cooking because it's done with a magnetic means, right? And I have questions like, wait, if I set my glass on the stove, will it melt the stove? No, it won't melt the stove. And I like to use this picture because since it's magnetically based, it will cook the egg when it's in the metal pan, and it will do nothing, as we can see when the egg is next to it. Let's talk about what I think of as the front line of electrification, which is electrifying emergency power supplies. High-rise buildings, let's say in the city, in the state, everywhere, require emergency generators that are traditionally, like the picture on the left, gas or oil driven. The front line really is trying to convert that into renewably supported electric battery systems so that we can really be operationally carbon neutral. The problem with this is that lithium-ion batteries, which are the predominant prevailing technology for batteries, are a fire risk. A lot of fire departments don't like them. The approvals process for replacing batteries is kind of convoluted. They're expensive, they're heavy. I actually kind of think we need technological advancement here, in as much as we've been watching for a long time flow batteries. You might not have heard of flow batteries, but we think that they're one of the battery technologies that is next in line to try and be commercially scalable. And they use like a kind of a chemical liquid to make the battery system work, but the best news is that they're not a fire risk, right? That's the real issue with batteries. So we're trying to get them on projects, and I would encourage you, as you work and discuss with MEP engineers, to try and consulting teams to try and push for it. One opportunity that we found in this space is relative to demand response. So when I need an emergency generator, let's say the code says I need power for 6 hours. And let's say a battery that does that is 200 amp hours, just to pick a number. If I upsize the battery to, let's call it 800 amp hours, I can monetize the battery by being a demand response partner with the utility company. Right now, I can discharge the battery, recharge the battery, discharge the battery when the utility company calls. In New York, in the city itself, Consolidated Edison has something like 25 demand response days a year. And you can actually turn a payback on battery systems if you do this correctly and you're willing to push through the approvals process, which is, again, kind of still first of a kind and tough. Let's come back to refrigerant for a minute, right? I think one of the most important things for MEP engineers to start to come to grips with is beyond operational carbon, embodied carbon. And the biggest arena there for us is with refrigerant. Let's draw our attention to the table at the bottom for a second. R12, which is Freon, that's not in use anymore, has a global warming potential 11,000 times that of 1 ton of carbon dioxide, right? So I've seen it happen, right? Unfortunately, refrigerant systems leak at recharge. I've seen where some of it slips away. I've seen it with my own eyes in front of the contractor, and it's like I almost fall down when it happens because it's one of the worst things that can happen, right? But so even R410A, which is one of the refrigerants that is in prevalent use now, still has a global warming potential of over 2,000. So what can we do as MEP engineers, and what are we doing as specifiers and as sustainability consultants? We're pushing towards the use of R744, which is carbon dioxide as the refrigerant. And since it's the reference gas, this whole table is normalized there, and the global warming potential as a refrigerant is 1. There are other enhanced refrigerants, and we're getting there. Let's talk about this first from an HVAC perspective, and then we'll talk about it from a domestic water perspective. From an HVAC perspective, the first question we ask is, do we need split systems, right? If we can have a packaged system, we have a lot less refrigerant out of the gate. If we have a split, we have a split. The problem we have in heating and cooling space is that while there's a lot of movement towards enhanced refrigerants, the equipment manufacturers in our space aren't really bringing them to market at the scale that we need them to. And as they're making advancements, the refrigerants come with a 10, 15, 20% operational efficiency hit. So in a way, we are gun shy from specifying these systems because it feels a little bit like robbing Peter to pay Paul. I get less embodied carbon in the refrigerant, but it comes with a 20% operational penalty. So we're waiting, watching, and trying to apply the right type of pressure on manufacturers in this space so they're aware of our needs. In the domestic hot water space, right, the hot water that's coming out of our showers and our sinks, we're making a lot more progress. Because to jump to the second bullet first, a lot of the equipment available has already come to terms with enhanced refrigerant. There are R744 domestic hot water systems at a large scale, central, and even mini splits. The real question in domestic hot water space is what refrigerant is in this equipment and what does it do to the coefficient of performance, which is the efficiency rating for the domestic hot water equipment. The large central stuff that is making domestic hot water with R744 isn't doing it with a very good COP, and it's not as operationally efficient as maybe a traditional gas-fired system would be, so it might lose. The mini splits, which are more capable of handling smaller loads, are doing a much better job in efficiency space. So when we have a building with smaller loads, a school like this, not a residential building, we would be looking to put mini splits in out of the gate. All right, as I move to closure, I want to draw our attention. That came out black. Interesting. As I move to closure, I want to push us. I want to kind of move towards this notion of circularity, which has been threaded through some of the conversation today. Right? We know we've had historically a linear economy, make, take, use, dump. The single-use plastic bag, which is finally basically on its way out, is a classic example of this, right? Whereas the notion of circularity is we've taken what we've needed from Earth. We've extracted the materials that we need. Let's use them. Let's transform them. Let's reuse them. That type of notion, right? So first bullet, as related to stormwater, it's another example where I feel very fortunate to work in the city of New York. The city has recently passed some legislation that has challenged how we manage stormwater. And so it asks basically that the stormwater management on a site resemble what it would look like had there been no building there in the first place. Pretend it's a grassy field. We are the city of development, and that drives us in many ways. But this regulation forces us to say something to ourselves like, are we entitled to develop? It really drives towards the concept of circularity. And so we are using this to find ways to infiltrate water into the ground, to reuse water from a gray water perspective and irrigate the plants and put green roofs on the roofs that collect and evapotranspirate water back so that we can start to really truly resemble the grassy field that we really should look and feel like in the concept of circularity. I'll give you two other concepts, right? Because it's hard to bring circularity a little bit mentally to how an MEP design engineering and consulting process works, right? The plastic bag example is easy. We're finding opportunities also on NYSERDA Buildings of Excellence projects to deploy wastewater source heat pumps. I love this because it's another really powerful example of how an MEP engineer and a sustainable design consultant can channel the concept of circularity. You can take the waste from our toilets and from our showers and put it in a tank, and you can extract the energy out of that and make domestic hot water at a very high efficiency. Why? Sewers, sewer water, sanitary wastewater runs between 50 to 70 degrees consistently. One of the frontline challenges that heat pumps have is their air source. They're taking energy from an air stream that is 0 degrees, it's 100 degrees, or their water source, and the water temperatures are fluctuating. Wastewater source heat pumps are going to find success here, much grander success here pretty soon, because they can rely on that 50 to 70 degree source temperature from our waste streams. Let's talk about how we can find synergy between symbiotic loads as a kind of a near closing point in the same type of space. And let's just refresh for a second on what a heat pump is, right? If I'm a gas boiler and I'm making energy by combustion, I am burning something, making a chemical change to release heat. Heat pumps move heat. That's all they do, is they move heat. When we cool this room, we're taking heat and we're sending it outside. If it's an air source heat pump, we'll pick on an air source heat pump. We cool this room by rejecting heat to the outside. When we heat this room, we're taking heat outside and we're putting it in. So we look in our design practice for any opportunity where we can find the symbiotic load leveraging the base root concept of what a heat pump is. And I'll give you an example. Let's pick on a residential building with a domestic hot water heating load. There's 100 apartments in this building. We need water all day, all year. And that is a consistent heating load that I can count on. So now let's ask ourselves, where are there cooling loads year round? Grocery stores, IT centers, fitness functions. These are the types of places where we're cooling year round. So when we come across a mixed use building where I need, let's say, residential domestic hot water and a grocery store downstairs, I am as happy as I get, because I can get fresh, I can take heat, I can exchange the heat between those two things basically for free. So I would challenge you all to kind of think and look for opportunities like that. Lastly, right, moving towards the challenge and closure, again, I want us all to use the platform that we have to advocate, educate, and participate for some of the things that I'm talking about, and us all being here is exactly that in the first place, right? Some of the things that I talk about, and this is more for me than for us collectively, but we need to find ways to pursue manufacturers and guide them to our market needs. It's great that you're working on enhanced refrigerants for heating and cooling systems. That's great, but I'm not really getting fully what we need to drive the change that we need with the urgency that we need to do so. Right, so MEP 2040, as for argument's sake, is a type of an organization where we can form, kind of organize and have a stronger mouthpiece in that type of space. Another way that I challenge myself and challenge us all is to partner with regulators and authorities having jurisdiction to advance the agenda. I think we have DOB in the room. I think Gina, Gina's going to follow me. I'm going to give us a live example. Gina is the Chief Sustainability Officer at NYC DOB. I hope it's okay that I'm trying this. I'm going to give a live example of how we can, in real time, outreach to our regulator. Really. And this came to me as I was making my slides, really. So in the city, for background, in the city, there is something called a fresh bonus, right? The city acknowledges, and if I say this wrong, forgive me, but the city acknowledges that there are food deserts. And for new construction, if you put a grocery store in a food desert, you get more buildable area and the building is bigger and it has a better operational performer, right? So I'm just talking about how I can pair heat recovery opportunities. What do I want on top of that grocery store? I want residential domestic hot water. So we don't have to talk about this right now, but like maybe we change the fresh bonus to say, if we come with some unique heat recovery system, we'll make the fresh bonus better, right? Because now we can pay for energy once and use it twice, right? This is the type of partnerships that we need to find. Let's go. Thumbs up. Thumbs up. Thank you, Gina. All right. So hopefully the tenor that I'm bringing here kind of feels like this already, right? But and the whole talk here, we know that combating climate change is the challenge of our time. It really is, right? And I'm fortunate to be here and have the platform that I have to impact the city, and to be part of helping impact the landscape of the city in these ways, right? I started our sustainability division about 10 years ago, kind of around the first bullet. And I would challenge us all to kind of think that way too, right? I mean, as an MEP engineer, you know, it's equipment. But now we lead with sustainable design first because we have to, right? There is a real urgency to this, right? And so I continually ask myself and my staff to ask for more. We try to think beyond ourselves. And of course, we need to stay practically grounded. Gina may hate what I asked for, but we're going to try. So I would hopefully I've inspired you to think a little bit like an MEP engineer and challenge others when you have that space to do so. Thank you so much.